They gave everything for this discovery, even their lives. We speak of scientific progress, but we rarely recall its toll. How many lives does knowledge cost? And who paid the highest price for a single deadly drop that seeped through a glove to a plutonium core? By the end of this video, you will learn about a horrifying tragedy born of foolish pride, a death that was absolutely senseless, and how a stone no larger than a baseball can kill a man in 25 days. It happened in 1945 in Los Alamos. Physicist Harry Daghlian was working on the final assembly of the plutonium demon core for an atomic bomb. He knew the risks. His hand trembled. He accidentally dropped a tungsten carbide brick and it fell directly onto the plutonium sphere. The reaction was instantaneous. A blinding blue light flashed through the room. It was the beginning of a deadly chain reaction. What did Daghlian feel in that moment? He quickly swiped the brick away, but he didn't realize that in those split seconds, he had received a radiation dose thousands of times higher than the lethal limit. Daghlian passed away 25 days later, suffering excruciating torment from burns and radiation sickness. But the most terrifying part? That core continued to wait for its next victim. 9 months later, another physicist, Louis Slotin, decided to conduct the exact same experiment. But why? Like Daghlian, he manually brought the two halves of the core closer together, using a screwdriver to prevent them from fully closing. It was absolutely reckless and irresponsible. He promised he could control the core, but the screwdriver slipped. The reaction was the same. A blue flash, but even more powerful. Slotin instinctively covered the radiation source with his hand. He knew he would die, but could he save the colleagues working with him? Slotin received a dose of radiation that guaranteed an immediate, yet delayed, death sentence. He died 9 days later. He managed to draw a diagram showing exactly where the radiation hit, and by doing so, he saved his colleagues. In total, the core killed 2 people, but there was a case where a scientist sought eternal youth. Is it possible to not just cure oneself, but restore youth through blood transfusions? The Russian scientist Alexander Bogdanov was convinced of it. He conducted a series of experiments on himself, believing that the blood of a young donor would give him a second life. In 1928, he decided on his 11th transfusion. He took what he thought was the healthiest guy. The donor was a student suffering from malaria and tuberculosis. Bogdanov did not perform thorough checks. Immediately after the procedure, he felt chills, convulsions began, and his temperature spiked. Why such a brilliant mind neglected basic safety rules? No one knows. He died 2 weeks later. The cause was blood incompatibility aggravated by infections. Paradoxically, a couple of decades after his death, blood transfusion became an official and carefully regulated procedure. This situation at least partially explains a somewhat rational mindset, but the actions of the next scientist are hard to explain. How can you discover 8 chemical elements, including oxygen, but perish from your own discovery? Carl Scheele, the greatest chemist of the 18th century, had a deadly habit. He tasted his discoveries. Seriously? He discovered tungsten, chlorine, barium, and even poisonous prussic acid. And every time, he did the same thing. Was this a scientific necessity? Or simply a fatal addiction that killed him slowly? In 1776, he died at the age of 43 from poisoning by heavy metals accumulated over the years. Though he discovered many elements, he never learned to distinguish scientific curiosity from suicide. That chemist died from accumulated poisons, and the next female scientist from accumulated radiation. Is it possible to be the only person to receive a Nobel Prize in 2 different sciences and yet die from your work? Marie Curie didn't die instantly in the lab, but every day of her work was a slow, irreversible experiment performed on herself. She carried radium in her pockets. She admired its glow. No one knew that this magic was literally destroying her body from the inside. In 1934, Marie Curie died of aplastic anemia caused by years of radiation. She gifted the world the atomic age, but her body became living proof of her own discovery, from the slow accumulation of radiation to an inevitable but delayed death. What can happen if just one transparent drop falls onto the glove you are wearing? In 1997, chemist Karen Wetterhahn was working with dimethylmercury, one of the most toxic substances on the planet. A drop fell on her latex glove. Karen didn't give it much thought. There were no immediate symptoms. The problem? Dimethylmercury doesn't corrode latex. It permeates through it. She was one of the most cautious chemists, but even her safety measures proved insufficient. Why did the deadly symptoms appear only 6 months later? After 6 months, Karen began to show neurological symptoms. Slurred speech, loss of vision. Doctors tried to save her with all their might, but she fell into a coma and inevitably died. Her tragedy was not in vain. She forever changed safety protocols for working with this poison. The next situation shocked the whole world and remains in history as a reminder of one fatal mistake. How can an ordinary routine safety test lead to the largest man-made disaster in history? The accident at Chernobyl in 1986 did not happen because of sabotage, but because of an experiment on the reactor conducted on the night of April 25th to 26th. Operators were supposed to check if the turbine, after shutting down, could generate enough energy to power the cooling pumps before the diesel generators started. They violated almost every rule. They disabled key protection systems, the voltage dropped, and in a desperate attempt to raise it, they made a fatal error that led to an uncontrolled surge in power. At 1:23 a.m., the first explosion rang out, followed by a second, which threw graphite rods and nuclear fuel directly into the sky. The victims of that night were firefighters, engineers, and a huge number of civilians who didn't even suspect what had happened or know about the deadly radiation spreading everywhere. They died not at the hands of an enemy, but at the hands of their own colleagues who broke the rules. Radioactive contamination affected over 200,000 kilometers across the territories of Ukraine, Belarus, and Russia, as well as parts of Europe. A 30-kilometer exclusion zone was created around the nuclear power plant, from which more than 115,000 people were evacuated, residents of Pripyat and other settlements. Is it possible to create the perfect breathing mixture for diving to super depths and be killed by something you couldn't predict? Sigurd Jung, a Norwegian researcher. In the 70s, he worked on the problem of decompression sickness and nitrogen narcosis, using a mixture of helium, nitrogen, and oxygen. His colleague nearly died in the first trial, suffering severe poisoning. Junge spent years perfecting the mixture. He conducted research to prove that the use of inert gases could reduce the risk of decompression sickness in divers. In 1979, he decided to test it personally in a hyperbaric chamber, simulating a dive to 300 meters. The mixture worked and he didn't feel ill, but when he began to ascend, something happened that no one expected. An unknown medical condition named high-pressure nervous syndrome. Junge died from pulmonary edema and a brain hemorrhage. This was not a mistake, not negligence, but death from a phenomenon unknown to science. He became a victim of his own risky trials. Despite the tragic outcome for Junge himself, his research and martyr's death influenced the development of modern diving medicine. His case is often cited as an example of a scientist who sacrificed his life for science. Take care of yourself and subscribe!